Good morning, everyone, and welcome to week 3 of our virtual school. I'm about to present 6.5.5. This is our classwork, page 290. So we did number 11 as our do now. Number 12, again, we're going to be given a verbal description for one of our companies, and then we're going to be given the graph for the other one. So this scenario is a comparison of two water companies and how much water they can pump. So again, our y-axis is going to be gallons, and our time is going to be minutes. And so we're going to make that comparison. So what they want us to do is to write a rule for each of the companies A and B, compare their domain and range, and then also compare their slope and the y-intercept. So what information are we given? We're given that pump A can move 48 gallons for every 1 minute. 48 gallons for every 1 minuto, for every 1 minute. B of T represents company B. So company B, they gave us the red, what I drew in red as our graph. And the only point that I'm going to call the friendly point, where it actually is easy to see, is where X is 20 minutes and Y is 900 gallons. So for 20 minutes, we're able to pump out 900 gallons of water. So in order to determine that slope, what I've gone ahead and done over here is I took 900, divided it by 20, and so the speed is 45 gallons every 1 minute times T is the number of minutes that the water is flowing. A of T is given as 48 gallons per minute, and so these are your linear models. Now the picture, I will say, is a little bit hard to see because looking at the interval, we're going up 100, 200, 300, 400, and so my interval on the y-axis is going up by 100. And in the domain for the x-axis, we're going up 2, 4, 6, 8, 10. So looking at or comparing those two slopes, that's going to be really hard to see in your graph because they're so close. A of T is 48 gallons per minute, and B of T appears to be 45 gallons per minute. So when you're drawing them, again, we know that A of T should be slightly above B of T. And again, it's very hard to see, but it should be a tiny bit above that red line, only 3 gallons per minute faster. So your graph, again, you would be doing this. 48 times 2 is 96. So 2 goes to 96, 296. 96 is a little tiny bit smaller than 100. Okay? And then 4 also. 4 multiplied by 48 is 192. So really just a little bit below 200. So again, a little bit hard to see. Let's compare, please, the domain and the range as they've asked. So for A of T, the domain is X goes from 0, but there really is no limitation on minutes, and so we're going to put positive infinity. The range will go from 0 also to positive infinity because in theory, we could pump that water out until forever, although we know in practicality that is not in fact true. We would eventually run out of water. For the domain of the company B, you have, and I apologize, it did wipe off there, that should be from 0 to positive infinity. So let's go ahead and write that back in. Domain goes from 0 to positive infinity, and note that 0 is included, but infinity never is. And so that I call it a hard close and a soft close. One is a bracket, one is a parentheses, and that is interval notation. Okay, taking a look at company B for the range, also it would go from 0 to positive infinity. Now what can we say about their slopes? The slope of A of T is 48 gallons per minute as opposed to B of T, which is 45. 48 es más que 45. 48 miles per gallon is greater than 45. Gallons per minute. 48 gallons per minute is greater than 45 gallons per minute. Both y-intercepts are at 0. And again, I understand that this is challenging to see. You'd probably be better off using Desmos, and you'd be able to see a slight increase in the AFT over BFT. All right, guys, let's finish up. Let's go to 13 and 14. Okay, 13 and 14 are given as a graph. As a grid or a table. So we're given two different companies that are car rentals. And so we're comparing the cost of each. So car company A charges 20 cents for every mile that's driven. Car company B charges 10 cents per mile, plus they're going to charge a one-time $10 fixed fee. And so I've set up that model for you. It's 0.10, which is 10 cents. You could also put 0.1 times D, which is the number of miles driven, plus 10, which is that fixed cost. And so we're just going to complete those charts. Again, this is 6.5.5 classwork for Algebra 1. And again, we're into week 3 of our virtual classroom. So they give us 0, 20, and 40 as our X values, and so I'm going to substitute those in. I apologize for the D. Substitute 0, 20, and 40 in. Well, anything times 0 is 0. 20 cents 20 times is $4. 20 cents for 40 miles will yield $8 for your fee. And so don't get bothered by this function notation. Just think of X comma Y, input, output. The inputs are 0, 20, and 40, and our outputs are 0, 4, and 8. And they correspond just like that. Okay, let's take a look at company B. Again, we're going to use the exact same distances, 0, 20, 40, because we want to do a comparison on price. So I've substituted the 0, 20, and 40. Please make sure when you're doing this in your books that you draw out and write all of the work. Okay? And again, here you see what I'm doing, and I'm equally as likely to skip some work. So 0 times anything is 0. 0 plus 10 is 10. If I do 10 times 20, I get $2 plus 10. That equals $12. And then 10 times 40 is $4 plus that 10. 4 plus 10 is 14. So again, just go back. Make sure that you're giving me all of the work if you can. So what do I get? 0 miles will yield a cost of $10 from car company B. 20 miles will yield a cost of $12, and 40 miles, $14. And again, this is number 13. After that, they ask you to set up a graph and to compare the two car companies. And so I've gone ahead and done that for us. So this line is your A of D, and this line is car company B of D. And if you've noticed, I didn't do this. This is in your book. They've chosen an interval of $2 for your Y interval, and we're going up by 10 miles for distance traveled as your X interval. Okay, so what do I know? They want us to compare and contrast the two different lines. And again, guys, where I got these dots is from this chart. So 0, 0, 24, 48. 0, 0. 0, 0 is here. 20 goes to 4. And 40 goes to 8. All right. And the second line, I have 0, 10, 20 goes to 12, and 40 goes to 14. So again, 40 goes to 14. I'm just going to write it right above here. Sorry, I'm not switching markers. Okay. And 0, 10 is right here. Okay, so let's compare these things. Well, A of D, that's car company's A y-intercept, goes through the origin. So the y-intercept is 0. B of D, the y-intercept is 10. Again, if I go no miles, I still have that $10 fixed rate. A of D, the slope, is greater than B of D. And again, just take a look. The steeper the slope, you can just take a look at that. And how do I know that? 20 cents per mile es más que 10 centavos. So 20 cents is more than 10 cents. Eventually, en la futura, A of D's cost, the cuesta, es más que B. So eventually the cost of A will be more than D. And again, you can see that you're going to see how quickly A of D's slope is climbing. 14, let's take a look at the chart, and then we'll do the graph. So 14, I have two cities that have snow. And so in city C, they tell us we start off with 8 inches of snow before a storm hits. And then a storm comes, and we're going to accumulate 2 inches for every hour. And so that's how we set that up. T time is in hours, 0, 1, and 2. Notice I've used parentheses to substitute the various times that are given. And when we do the calculations, 2 times 0 is 0 plus 8 is 8. So 0 hours, we start off with 8 inches that have already fallen from a prior storm. And then we do 1 hour, 2 times 1 is 2 plus 8 is 10. And you get 1 hour, una hora, es 10 inches. Then I go to 2, 2 times 2 es 4 y 8 y 12. So 4 plus 8 is 12. So after 2 hours, I get a total of 12 inches of snowfall. We go to citywide. They give us a verbal description. There are 8, I'm sorry, it's not inches, it's centimeters. I apologize. Y has 8 centimeters of snow already, and the storm is accumulating 1.5 centimeters of snow every hour. This is given as a verbal. Here is your linear model. Y of t is equal to 1.5 t plus 8. So again, this is hours, and my snowfall is in centimeters. This is in hours, and my snowfall, the y's, are in centimeters. So I go ahead and substitute. I have 1.5 times 0 plus 8. 0 plus anything is the number, okay? And so I get 0 goes to 8. Sorry again, guys. Using dry erase board, sometimes they scratch each other off. Going to, after 1 hour, 1.5 times 1 is 1.5 plus 8 es 90 y medio, or 90.5 centimeters. 1 goes to 9.5 centimeters, and 2 hours will give me 11 centimeters. So the next thing they want us to do is they want us to compare, graph them first, and then compare them. So here we go. Here are my graphs. Notice they both start at 8 centimeters. They both start at 8 centimeters. However, the C of T is different than the Y of T. C of T is falling at 2 centimeters per hour, whereas Y of T is 1.5 centimeters per hour. So C of T's slope is greater than Y of T. 2 centimeters is bigger than 1.5 centimeters. So let me just give you a little bit of help over here. So again, looking back at this, 0 goes to 8, 1 goes to 10, 2 goes to 12. 0 goes to 8, 1 goes to 10, and 2 goes to 12. Okay? And then for the Y of T, let's just go back and see where that came from. So it goes 0 goes to 8, 1 goes to 9.5, and 2 goes to 11. So give me 1 second here. Switching out my markers. And again, some of them are, I'm switching these out constantly. Let's go to blue. Okay, 0 goes to 8, 1 goes to 9.5 centimeters, and 2 goes to 11. Again, 11 is en la media between 10 y 12. Smack in the middle of 10 and 12 would be 11. 9.5, you're going to have to eyeball it. Smack in the middle is 9. So 9.5 should be a little bit higher. That should probably be a little bit higher than that. But again, you're estimating there. Have a great day, guys. Continue up the good work. Make sure that you show all your work and make sure you upload everything into Google Classroom. Have a great day.